Hello everyone, welcome back. So today we are going to solve one more interesting problem. Uh, its name is word search and its number is 79. So basically what is the problem? So we will have a m cross n matrix with the characters, and we will be given a one word, and what we need to do, we need to find out if that word is available inside of a matrix. If yes, return true. If no, return false. And how we need to find out? So the constraint or condition is we need to found in a neighbor, which are the adjacent cells, in simple words, up and down, left and right. So for example, in this case, the word is GKJI. So this one is G. After that, if I move down, I have K. Then if I move on a left side of this one, adjacent neighbor, J and I. It means I can return true. In case of this NOPLZ or Z, we can check. So I have this N, O, P, then L, and there is no Z. Is there any other possibilities? No. So we will return false. So that is our question. So it's a pretty straightforward question. Only you need to understand 2-3 things. We already discussed in the other problem solving videos, but I will repeat again and again. First thing, these type of questions are expecting a lot of code. So you should be ready and you should write some things very fast. We will discuss that, because in 1 hour or 45 minutes, if they ask you 2-3 questions, you have only 10-20 minutes to write a good solution which should work. So before going towards this problem, we can discuss a little bit more about. So every time when you have a matrix, there are 99.9% chances you need to scan. So you should be ready to write 2 loops, and so for example, matrix dot size. So this one is a 2D array, and then j in 0 until 2D arrays first array dot size, so it's a second. So this code, we can say, okay, this part is a scan of a whole array, whole 2D array or matrix. So this one is, you need to write this code in any case once you are going to play with matrix. Okay, now the second part, which is again important. So once scanning, you need to write what type of constraints. So there are some generic constraints which most probably are always there in case of a 2D array. You should not go outside of boundary. So in this case, our I and J are inside of a boundary, they will never go outside. But some cases you need to explore. In those cases, you always remember you are not allowed to go outside. So if we say I and J, they are our, or X and Y, I always greater than equal to 0, and I should be always less than of matrix dot size. So basically this condition is we are going to play inside of a matrix boundary. If you are not following this condition, it means you are going outside of boundary. It's like an index out of bound, so you should not play with that. Or if we revert this, what we can say, I is less than 0, or I is greater than equal to mat dot size. So in this case, if I is less than 0, then it means I'm moving kind of a -1, -2, or if I'm moving I greater than mat dot size or equal to. because it's a zero index. Most of the languages support zero index array. So in this case, I should not do any next thing. And this is same for J. But the difference will be, it's always go with mat.I. So it means if this is if, most probably you are writing something around, okay, or, and this I. So if you are 100% sure if it's a matrix, always n cross n, it's a square matrix, then you can go without this mat.size. But in case if it's not 100% a square matrix, then always use I, so there will be no index out of bound. So two things: one, you need to do scan in any case, that is 100% sure. And if you are going to explore, these conditions are very important. There are most of the time these are the bugs which always create some issues when you say, okay, now I'm done. But the validation, it's pretty easy. Maybe spend 10 to 15 minutes on a paper and you will understand by going, okay, what is this, what is that. Then the third part, every time when you have a problem in which you need to scan, you need to move, there is one tricky problem, tricky bug. I will try to how to show you. Okay, so for example, we are on a cell K. I want to check above, left, right, and below. How we will do, and I will say this is a x and y. So x, y. So if I want to go up, which means I'm going to change x minus 1, y means I'm moving up. If I want to go down, it means row is increasing, x plus 1, y is still same. If I want to move on the left side, it means row is same, and I'm moving the column and increase of a column. So in this case, if I'm on K, I'm saying, okay, go up, which is G, go down, which is O, J, and L. But what happened? There is a one tricky part. So once, for example, I move to this part. So now my center is, for example, x, y plus 1. Okay, now I need to apply the same conditions. So now in this case, if I want to move on the right side, it should be x, y plus 2. If I want to move up, x minus 1, y. Maybe it's a y plus 1 basically, because that column, like in this case, for example, y plus 1 means we are at this L. So in case of a L, now I'm exploring again, then x plus 1, y plus 1, and now x, y, because y minus 1 means minus 1 and plus 1 is gone, and we will be on a y like this. So in this case, y plus 1 means this cell 0, 1, 2, 3, and the y is 4, 3 and 4, and this one is 2 and 3. So you can see I moved from here to here. Now I'm saying also run for this. This means we are stuck in a loop. That is an infinite loop, and most of the time in the matrix related questions, this is the only one tricky part. After boundary condition, then this is the one tricky part. So you need to remember, you already visit or not, kind of in graph, you know, we do the same, so it's same. So you need to remember, you need to figure it out, some condition that should save you from this infinite loop. So if you already visited something, it means you should not go back on from where you are coming. So that is the third thing. And how we can manage this? There are always two ways to tackle this situation in a question. I'm not talking about this question, generally. So if you are not going to make a in place, it means you are saying you will create your own matrix with the same size. So for example, I have a question 1, 2, 3 and 4, and I want to make sure I'm not doing the same issue, the bug. I will say okay, I am going to create a one same array. Maybe I can give a name visit it. So once I'm here, I will put some value, maybe uh, something like. So I'm always checking in my code if on the same cell, if there is static, it means I already visited, it means don't go on that place. Now I move to this place, so I'm going this, then I move this place, I'm going this. So by taking an extra matrix, I can take care of the visited path. So when from here my code will say okay, go back, and I'm going back, but I'm check okay, this is already visited because I have this value, it means I can't go, and you can save. But in this case the space complexity will be increased, so you will say okay, we go off the size of the given matrix. And sometimes in some cases, if you spend little bit time on the question, or maybe the interviewer will ask you, can we improve the space complexity, maybe we go off 1, it means he's giving you a hint, try to figure it out. You can do the same thing in place. In place means the given matrix you can change, you can play with that, so you will remember you already visit that path. We will see in this scenario. So moving towards this problem, I want to repeat again. First, every time when you have a matrix question, most of the time you need to scan. So write 2 loops, that is 100% sure. Okay. Second, if you are going to explore, somehow you are going to play with this data going up and down, it means you should take care of the boundary condition, and boundary condition is always same. I should be greater than 0 and less than the size, and j is also the same. And then the third condition is if you are going to play inside visiting path, you need to remember you already visited or not, otherwise it's an infinite loop and your problem has bugs. Okay, now moving towards this question. So we need to fix this question, we need to solve this question. What will be our strategy? I'm going with the same strategy. First, I have a function fun, maybe word search ws, where I will get a matrix and I will get a word, and I'm returning boolean. So this is our main function, and we already discussed in this case there is no need to discuss. Try to write directly I in 0 until matrix dot size, and then j in 0 until matrix of I dot size. So until this point we are sure. Then there should bracket close. If my code can come at this line, it means I'm not able to figure it out. The answer return false. So this is the first part. Scanning is there. Now the next part is we want to do a search. So DFS, BFS, or maybe I'm not using those terminologies. What I will do, what we want to do, basically we want to check at every location if that word is matched or not. So for example, in this case, I will take A, I will check word. A is equal to G, it means this is not my word, because I'm sure my word is, if this one is one start, this should start with the comparison. So A is not G. Okay, what's next? B is not G. C, D, no. So basically, simple like this, you can say if a matrix of I, J is equal to word of 0. So first character. So in this case, we will check one by one until we find the character. So we find this G and this G. So it means now it's equal. It's time to jump in and to explore this path. How to explore the path? So I will write a code which is recursion, but sometimes this gives tough time to the newcomers. Like for me, I still struggle sometimes, then I need to take a copy pencil and then I write. So what we need to do, at every element, I want to check left, right, top and bottom. And I want to confirm, okay, if the next letter, which is K, I need to check, okay, in case of top, is it K? No, it means there is no need to go on a top. Then left, right and bottom. So how this will work, at every cell, we have a strategy like move up, right, left, down. On every cell, move up, move down, move left, move right. But this is not a parallel or concurrent code. We will do one at a time. So in learning, you can see, but once we will implement, computer is doing one at a time. That is the first point. So how we can achieve this point? It's pretty easy. I already showed you. So if this one is a x, y, x and y, we only put x, y plus 1, x y minus 1 and x minus 1 y and x plus 1 y. So I hope you understand this is the algorithm. This is the algorithm which will take us to explore the path. Move on this side or move on this side or move on up or move on down. After that, once we are doing this, we need to do this. What is the second condition? Basically the problem. The problem is I need to compare these characters with the given character. If I can compare and I can get the whole string in this one, in any case like G, K, J, I. So basically I started from G, then it means I'm going move down, then on a down I'm move left and then we able to explore and we can say, okay, I found this string, it means it's true. So now we need to implement this. So I will have a one function which I need to call from here. That maybe I can say search, SEARCH. What things I need to pass? One is this matrix. Second, the row and column which we found have a same word, same character, I and J. Then the word string. And then once I found word at 0 index, I need to move also that to the index 1. So basically index. Again, matrix I need to pass pretty simple, I and J pretty simple, word is pretty simple. What this index? This index will help us to find at what index now you need to compare. So in this case, once I found G at 0, it means now we need to compare this index 1 and I need to send that index. So my code will understand, okay, I need to compare index 1. Now how to implement this? So fun search matrix I J word and index, and this will return boolean. So in this case, if this will return boolean true, so it means if this search is true, I can return true. Yeah, because we found our answer. Okay, now this will be a recursive code. How? Because you know, once you want to explore something from the computer perspective, it's always a recursion. You can't write an iterative code which can explore infinitely. So in case of a recursion, we can easily understand, okay, this search will call again to itself, and how that will be called we already discussed. So if I'm on a cell and I want to move up, in that case we will discuss about the base conditions later, but I'm first writing the simple code. So matrix is there, I want to go move up. So up means it's a y minus 1 and I, so I should be same, and there will be j minus 1 word, and index should be plus 1. So this is only I'm moving up, but we discussed we need to move on a 4 sides. So we need to tell to the computer we need to move a 4 sides, but computer is saying I will do 1 by 1. So that you need to remember. Then the same search I j plus 1 word index plus 1. Basically index plus 1, or I can, it's same value. If it's 0, if I am getting 0, so I'm sending 1 1, because I want to check now the 1 condition with all these 4s. Then search mat I plus 1 j word index plus 1, and then search mat I minus 1 j word index plus 1. Okay, cool. And we know this is a boolean, the return value will be boolean, so we will discuss that also. So until now what we did, we will take that one value which is coming from here, and then we are saying okay, we will start first, I will go up until maybe I found the answer, or in case if I don't found the answer, the recursion will come back at this point, and that will start this recursion, this method. In that case I will start going moving down, not down, instead I will say moving down, then it will come again from here, and j minus 1 will go up. So here we have a loop issue, we already discussed that, we will fix here somehow, and then again coming here down and up. So you need to spend little bit time on a paper by writing this code simply, and try to make a small graph, and you will figure it out, okay, what I'm saying, up, down, top, left and right. From the code perspective, for computer this code is enough to explore. From the human's perspective, you need to make a kind of a map in your brain how computer will work, how computer will execute this, and you need to understand that. Once that is done, now we are going back to our base conditions. So you guys remember we already discussed one base condition which is the most important one. If I is less than 0, it means how that can be possible. That can be possible, index is 0 for example, and now we are here. So 0 minus 1 is minus 1. So it means I can't give you the permission to go to the next. It means this is a false or a base case or a false base case. Or I is greater than, maybe greater than equal to mat I dot size. Sorry, this will be a first dimension, so mat dot size. So in this case, how can we can achieve this boundary condition? I plus 1. So for example, I am 0 1 2 3. So 3 plus 1 4. 4 is greater than is equal to mat dot size. Yeah, 4 is equal to 4. So equal is also okay. But sometimes I'm like, I always scared from these type of conditions, so I'm writing, but I'm sure this will never happen if you write the I is equal to mat dot size. Okay, so this is done. What's next? I need to take care of j also. So j is also same. J is greater than equal to mat of I. This is also important, I dot size. So until now, these are the conditions, and how we can break this one, you can break by using this j minus I and j plus I. So now I hope you understand what I am saying, the boundary conditions when you are exploring. This one is 100%, we are good to go. What's next? Next condition, how we can also return. So for example, in this case we have a G. I send this information here and index is now 0. This one should be passed. At this case G, and we are saying okay 0 J minus 1. So this one is a 0 1. So first time I am sending that value 0 1 2 0 1. So basically this will be 1 2. So I is 1, J is 2, which is pretty okay with this condition. Then I will move here and I will say, I will call again this method with 1 1. J minus 1 is 1 1. Okay, 1 1 means J, I and J. So this one is 1 2 0 0 0 1 0 2 0 3, and this one is 1 0 1 1 1 2 1 3. Now in this case what I am sending matrix is 1 and the J is going to be changed J minus 1, which means 1 1. 1 1 means okay, sorry, basically we are changing the column, J's column. I confused this. Okay, so now we are moving on a left side F, and my index is 1, index plus 1 is 1. So I need to check at this position is it equivalent to K. If not, it means there is no need to explore more. So that is a simple condition. Or word of index not equal to mat of I and J. So I'm going to repeat again, hopefully you will understand. So basically we want to compare like in case of string, only string, when you compare with the single dimension string, like for example equal method, in that case what happened, you do linear scan 0 to 0, 1 to 1, 2 to 2. So we have two strings. I'm saying 0 index with 0 index, 1 index is 1 index. In this case the difference is we are comparing a linear or a string with a two-dimensional. So in that case with a two-dimensional we need I and J. That is a common sense, you need to play with two-dimensional. So in this case what we did, okay, G is okay, we passed this condition. Now I'm saying go inside. Once we are going inside, it check this one is passed, but there is a problem. This is F and we need a K. So in this case I am saying okay, this is F. So all these are passed, but originally the problems which we are solving, in that case it's saying no, it's wrong, then return false. Okay, so in that case this is going to return false, which makes sense. What's next? Then this recursion is complete. From here we get the false. Now we are moving towards this. J plus 1 means 1 3, so H is also false. So once this will move here, go until this condition will stop this and then return false. Then what else? K. So I plus 1 means this one, 2 and 2. So 2 and 2 means K. G and K, K and K is true. This condition will be passed. Then we will move again here. So we are started from this, then we move this, and now from here we are starting the next step. So basically in that case our index is now 2. So now we are playing with the 2. So now we are looking for J. Yes, as a human being I can see J is there, but as a machine code, machine don't understand like this. So what machine needs to do, here is 2 and we will have now the next terms. So this one is 2 and 2, 2 and 2, before that is 2 and 2. Now once it will come here, it will say okay, K is good, we need to figure out the next one, so it will throw this. So 2 1, 2 1. In that case what is 2 1? So 2 1 should be this, which is J. So j, in this case it will pass because this one is yes, and then we will move again and we will get I, and that will be passed. For example, we wrote this condition first, I minus 1. So I come here at k, and I minus 1 means I'm going back to the g. I need to stop this, so you are not allowed to go back. And how we can do that? So if I will take an extra visited array, I will put here visited, and I will add that when I'm going in a visited, put the I and j should be some value, and then check, and from here I will update. But I'm going to do in place. In that case, how we can achieve that? So in place means I know this is g, and we also know this g is also available in a word. So now I will write a one code. So we have a mat. I'm saying I and j, the index which we got, go and update with something which is not available here. So these are all the characters, and we know in the question these are all always string, the alphabets. It means A to Z. So I'm going to use maybe character 3. So I'm saying okay, update this with 3. So in this case, once this is passed, the 0 1 is going to be passed. I'm saying okay, move this to 3. Now the benefit of this 3, if somehow I will move from here back towards this, I will check index and my string g. G and 3 both are not equal, so it means it will return. So in this case, I can save that infinite loop. But now the problem is we are losing our matrix, and we need to take care of this value as a g, because there is a possibility from this g that the word which we got is POKG. So in that case, if I remove by 3, how we will figure it out? So in that case, what I will do, I will say okay, mat of I and j, the same update with the word of index. So in this case, what will happen? Once, if all are returning false, it means I will come at this place and I will say ij, which is this, update your value with word index. And at a word index, we have a 0, so I'm saying okay, g. Now this is the power of a backtracking in a recursion. So from here, I'm moving towards next. I'm using in place visiting. So I change that value, but I know I can track back that value by using the word, the string. And we know that will be only passed if on the same index we have the same value on a word. I hope you understand. In case if I need to use a separate matrix, like I spent some time and I'm not able to figure it out how to manage that, don't spend a lot of time, create directly a complete matrix and start updating here, and from here you can start removing that. Maybe you can use some kind of an array list or maybe set in which you can put that value, okay, ij, this one is done, then this one is visited, and then here you can check like set dot contains. If that value contains, it means you already visited, so return false, and later you can spend time here, because the most important part is you should solve a problem and then improve that. So by doing this until we are good. Anything else? Yeah. So where we are returning true, we are not returning true anywhere. So that will sorry. So that will be our success base case. What I need to do, I need to check. There will be more than one ways, but what I think is the easiest one, I will say okay, word dot size is equal to index. It means we found. Return true. How? So in this case 0, 1, 2, 3, and we found this. Now next time at 3 somehow somewhere it will send this 4 and x plus 1 4. We will be here word dot size is 4 is equal to 4. It means we are damn sure we found that string and that will return true. So in this case I think this will be enough to figure it out. Now still it's not complete. What about here? So I can take a one value maybe result equal to this, and I can put or the by putting or, you know, in case of a or, true false is true, always true. So if we found true, it will return the result is always true, and we can return from here result. Okay, this one we only need a 1, so I will try to divide. That makes sense. So this is our second function. There is also one more benefit. So basically, if I found at any place 1 is true, then what will happen on a return? It means there is no need to execute others, because this is a OR operation. In case of a OR operation, if first is giving us a true, the compiler will not go to the next conditions to check. So by doing that, I will save that true, and then I will return from here the result. And in case if all are false, it means that is a false. I will update my matrix, like I'm saying, okay, return back, I'm not visited, and then go back. So this is the whole question. Now it's time to discuss the time and space complexity. So for time complexity, always this one is always big O of m into n, or maybe you can say big O of n, and n is equal to number of elements in a matrix. So it depends how you want to explain, but don't say only big O of n. Please explain what is n means. So that one is a big O of m into n, and then what will happen at every point we are exploring 4, but after 1, like for example in this case I explore this and this, then I will move here. In this case I will always explore 1, 2, 3. Then if I move here, I will explore 1, 2, 3. If I move here, I will explore 1, 2 and 3. The fourth one is only first time, but every time we will explore 3 paths for the each element. So it, and how many times we will do in that case, it will be the length of a string. Like for example, I have a matrix which always go to be true until the last element, and last element is always returning the different, and like for example the last element is not compared by true. It means in that case I will explore every time 3 power L, because element, then for that element. So in this case we can easily see big O of m into n into 3 power L. Here L is equal to the length of a word, m into n is the matrix, and in case of a space, so in case of a space we are not going to take any extra space, it will be in place. But what is the maximum stack as a recursion? So at one point my maximum stack can go length of a word. How? Like for example, in this case, I never go beyond 4 characters. I always go less, because at any index, if index is not passed, if that does not compare, it means it's returning from there. So in this case, the maximum path, what will happen in a maximum, I will go until maximum of 4 stacks, like from here, then I will move here. Then for example, I moved here, this is L, so I will never go beyond this, I will return back. But from here stack and moving here. So the maximum is big O of L in my opinion, hopefully yes. So that will be our space. The maximum in a stack, we are taking this, but in place. And in case if you are not taking in place, you have a separate set which is taking care of the visited, then in that case what will happen, you can save maximum also L number of, no, you can say more than that. So you can say M into N for the extra matrix and then plus L. Yeah, hopefully that makes sense. Okay, so going back, repeat one more time. I think today I repeated a lot, but this is a very important question because there are hundreds of questions on the same kind of a technique which we need to learn every time when we go with the recursion and then the matrix. So every time when there is a matrix, always remember you need to scan in any case. So 2 loops should be there. Then there should be some condition which is going to help us to start exploring DFS or a BFS approach. But in case of a matrix, I always use terminologies going up and down, below and up. It always makes me more easier to understand that question, not going with the BFS. But in some cases, you need to go with the BFS if you need to find out the shortest path. But that is a different story. For now, we can focus on scan, 2 loops, which you need in any case. Then if it's an exploring question, the boundary condition, which is always same in any case. Then you need to figure it out, what is the question basically, and you need to prove that. So you can put your condition here. In case you are using extra memory for the visited path, then you need to write a one more condition, or it's not already visited, otherwise return false. Then you need to write simple 4 lines of code. Basically it's like up, down, left, right, and from there you are getting some data, some result, and you need to return result. If you are not using extra memory to remember the visited, it means you are playing with the in place. Then you need to remember, you need to recover your matrix. And in some cases the question is like that, there is no need to recover. So once you change, nobody cares. It depends on our question. But if you spend 1 or 2 minutes, you will figure it out hopefully, but you need to do a practice. Then in this case, most of the time you have 2 base cases. One is for your true case, one is your for false case. In some questions, maybe you need to do something else. There is only one false case, and this is the place where you need to do some stuff. I will try to figure it out more questions around the same thing, and we will discuss more. So hopefully I share with you something new. So yep, see you in the next video. Bye.